A global sustainability challenge that we are facing today is to nourish growing population. At the meantime, we need to reduce agricultural environmental impacts. That means we need to reduce environmental impacts from our agriculture. Today, we are producing enough food to feed 7 billion people. However, we are having around 800 million people undernourished and under hunger. This is the bitter reality of today. And our agriculture causes several environmental impacts. For example, agriculture is one of the major greenhouse gas emitters. We have problems regarding soil degradation, eutrophication, heavy pesticide use due to our agriculture. Further, our agriculture practices today also require huge anthropogenic inputs, such as fertilizer and irrigation water and agrochemicals. Our agriculture causes environmental impacts. In return, our agriculture is also affected by these environmental impacts. Yesterday, we already heard or we listened to several presentations stating impacts of climate change on our crop yield. And when we talk about the future, what we need to consider is, in the future, we need to produce 60 to 110% more food than we are producing in 2005, and it's coming from mainly population growth. We need to feed 9 billion people, but not 9 billion people only. These people are richer than today, or will be richer than today, and will have different lifestyles. So population and changing lifestyle will be driving our future food demand. So to tackle these sustainability challenges, including feeding the global population in a sustainable manner, in 2015, world leader has agreed to achieve 17 Sustainable Development Goals, which consist of 169 targets. And several of these Sustainable Development Goals are quite linked with agriculture and issues related to food security. Before going to the research results, I would briefly like to mention that most of the analyses I'm presenting today are based on freely available data set, like FAO Stat, like graded livestock of the world, also using FAO YASA model on global agroecological zone. What I do is, I don't do much model simulation, but I use empirical and model approach to analyze this data set with a global, regional, and local focus, and to provide specific answers. I use tools like artificial neural network, scenario analysis, and so on. And one of the research results is dietary habits, which is amount of food we are consuming and the composition. And this is the results. This is the result based on FAO Stat data set for the last 50 years about food consumption in different parts of the world. What we can say is, in last 50 years, based on this data set, is that we can identify 16 typical dietary patterns that exist across the world for the last 50 years, which consists of low-calorie diets, moderate-calorie diets, high-calorie diets, and very high-calorie diets. What is interesting here is high-calorie diets are mainly, with large share of animal product, are typical for most of the developed countries, whereas transition countries have high-calorie diets. Depending upon the region, there may be a higher share of cereals or animal product, and here this moderate and low-calorie diets are typical for the developing world. But what we need to remember here is the food composition or this sort of diet is not static. Countries are moving from one dietary pattern to another dietary patterns. And this change in dietary pattern is driven by Human Development Index. Here in these graphs, you can see Human Development Index in x-axis and consumption of different food group in one y-axis. With human development, we can see increase in in total calorie consumption in a country. Also, a lot of consumption of a lot of animal product, sugar and sweeteners, oil crop. And the good news is also consumption of a lot of vegetables. This is important because when we talk about the healthy diet, we need to consume sufficient amount of fruits and vegetables. But the problem here is we are also increasingly consuming a lot of animal product across the world with human development. And when we talk about this sort of diets, it matters because our environmental footprints are determined by what we are eating and how much we are eating. This is an example of this. Here, in the y-axis, you can see the amount of food consumption in these 16 dietary patterns, and here is the amount of fossil energy used to produce this diet. And the colors of this graph shows amount of greenhouse gas emission, agricultural greenhouse gas emission embodied in these diets. Higher the calorie we are consuming, higher fossil energy we are using. That means in this area, we are using 1 calorie of fossil energy to produce 1 calorie of food. In other words, we are not eating food, but we are also consuming fossil energy to produce that. That's a lot. Second thing is like these diets are also greenhouse gas emission intensive. So by consuming a lot of calories, we are also contributing to climate change. An interesting thing is like all these arrows shows how the diets are changing in last 50 years. And most of these arrows are pointing upward. So the global trend is towards this high end. So we are living in the world where we all are trying to reach over here. That means high calorie consumption, having high environmental footprint in terms of energy use, in terms of greenhouse gas use, in terms of water use to produce this food. And if we continue to do what we are doing now, what may happen is like by 2050, agricultural greenhouse gas emission may double, which can be, okay, which is shown by this graph, and this is by considering changing dietary patterns. If we are only talking about population growth, not dietary change, greenhouse gas emission from agriculture may not increase so much. But with changing dietary patterns, it will go further. But the good side is we do have technology today, the available technology today. If we transfer the technology, what we have in developed country to the developing world, we can definitely reduce greenhouse gas emission from agriculture sector. So one further thing here I would like to mention is this is one aspect of our food sector, like in greenhouse gas emission associated with our diet. I also mentioned already that we are using a lot of crop to feed our livestock. That could be the second dimension. What we can see here is amount of crop we are feeding to our livestock in one of these regions like North America, Europe, or Southeast Asia. This amount of crop we are feeding, using in this region to feed our livestock is enough to feed or enough to nourish 800 million people which are undernourished today. So in other words, in this region, we are taking out food to feed cattle or pigs in this region to fulfill our increasing meat consumption. And that's a lot. And we can see here different regions where they use a lot of livestock feed, like in Europe, Southeast Asia, partly in the United States. Currently, only 60% of produced food is used to nourish human being. Rest of 40% of the produced food is used to feed our livestock. That's a lot. And here what we can see is this is not uniform across the world. There are some regions mainly marked by these red lines here where more crop is fed to livestock than the amount of crop they are producing. So there are regions where they are producing crop to feed only livestock, but also importing a lot of crop from other regions to feed their livestock. And in general, we are using 4 calories of crop to produce 1 calorie of livestock. That means 1 calorie of animal product. That means animal product we are consuming is energy intensive, not only in terms of fossil energy, but also in terms of crop energy. And this is a picture, a global average picture. But when we look at different regions across the world, what we can see is there are regions across the world where they use more than 10 kilocalories of crop product to produce 1 calories of animal product. The good reason is there are also some regions where it's mainly based on like a rangeland or pasture where they don't use much crop to produce livestock product. And when we talk about future by 2050, the crop, if things goes as it is now, we will be using more than 50% of produced crop to feed our livestock. In other words, by 2050, our farmers will be producing more crop to feed livestock than to nourish human. And the second aspect, or another aspect on the food consumption side is food waste. We already heard yesterday that we are wasting around 30% of the produced food. Before going to food waste issue, I would like to highlight a bit more on food requirement. What we can see in this map is the food requirement for different countries across the globe for year 2000. And the food requirement for a person depends upon the person's body weight. Larger the body weight, more food a person needs. Physical activities level, that means a person who is doing a lot of physical activities needs more food. Also the age group, adults needs more food than elderly or kids. And in a country scale, it also depends upon the demographic pyramid, where it's like a triangle or quite flat. And what we can see is like countries with larger body weight, like in United States or Europe, they need more food than the countries where they smaller body weights. So this is the story of food requirement per person on a country level. And when we look at a food requirement per person on a global scale, what we can see here is the food requirement per person in 1965 is around 2,300 kilocalories per capita per day. What is that in 2010? It hasn't changed much. It's around 2,400 kilocalories per capita per day. That means in last 50 years, per capita food requirement, looking at the biophysical, looking at the body weight and so on, hasn't increased so far. But interestingly, food available in the global market for human consumption has increased a lot. It has increased from around 2,300 kilocalories to around 2,900 kilocalories today. So we can consume around 2,400 kilocalories of food per person, but in our market we have 2,900 kilocalories of food per person. Where the difference is going? This difference is going as a food waste. So in last 50 years, we definitely achieved hunger reduction. We definitely achieved to feed the growing population. However, the interesting part here is we are also contributing to a huge amount of food waste. And when we talk about the future, what we can see is the food requirement will not change much. This is the exercise done on demographic projection for 2050 using different shared socioeconomic pathways provided by APCS. It doesn't change much. Food requirement will still remain constant. But when we look at different food demand projection, like one mentioned yesterday from FAO, which projects around 60% of increase in food consumption, what we can find is the demand is increasing, but the requirement is not much. That means the future increase in food demand is not coming from real energy requirement for human consumption. It's going from the food waste. If things continue like this, we will be wasting 1,000 calories per person by 2050, and I think this is too much. And where we are wasting this food, and how this food waste is related to different countries, we can see here. We can see in this axis a ratio which is representative to food waste, and here in the y-axis we can see the development state of different countries. And what we can see is more developed a country is, more food we are wasting. That means development is, or wasting food is analog to our development. And I think this is not the nice trend. There are some exceptions for this, like Japan having a huge human development index, but relatively less food waste. And when you talk about the food waste, we also need to remember Sustainable Development Goal 12, which has a target 12.3 to halve the food waste. So I hope the projection I showed before will go wrong, because by 2050 we need to halve the food waste. That's what our global leader agreed on 2015. Reducing food waste matters because it also contributes to mitigate climate change. When we are wasting food, we are also emitting greenhouse gas emission from agriculture unnecessarily. And it has been increased with the food waste in last decades, and it will increase further in next 50 years. So if we manage to reduce food waste, we also manage to mitigate our climate change let's say even though it will be in a very small extent. So this is the story of food consumption side. When we talk about the food production side, there are regions in the world like Africa, South Asia, parts of Eastern Europe and Central Asia where they haven't produced enough food, or they haven't produced food that is up to their potential. They are far below their potential food production. And we are talking about need to double the food production by 2050. And traditionally, we are using two strategies to increase the food production: intensification and agriculture expansion. When we look at the story of agriculture expansion, the suitable land for crop production for agriculture expansion is not uniformly distributed across the world. There are some regions in the world where there may be some land available for agriculture expansion, but there are many regions in the world which is highly populated. There is very limited or no land available for agriculture expansion. That's why when we talk about feeding the growing population, we also need to focus on agricultural intensification, looking at different strategy to close crop yield gap. When we talk about closing crop yield gaps, we used to hear that, okay, we need fertilizer, we need water. These are the two things that are highlighted quite more. But what our study shows is we don't only need fertilizer and water only to close crop yield gaps. There are also different socioeconomic and biophysical factors that are causing those yield gaps. And this is a map of the world where we say, where we present different strategies required to close these yield gaps. Like in some location, we need to improve the soil quality. In some location, there is no road, so that farmer doesn't have access to the market to buy fertilizer and also to sell their agricultural product. So in some places, we need to develop road network or road infrastructure. In some cases, there is so much agricultural climate crop yield variability. So climate is so much fluctuating that farmer doesn't want to risk their investment. In that case, maybe there is a need of crop insurance or something like that. And there are locations where we need pest management. And there are most of the locations in the world where we need mixture of these inputs and management. And then the next issue on a food consumption side, also in the closing the crop yield gap is require fertilizer to close the yield gap. Phosphorus is a limited resources. We can produce nitrogen as much as we can, but it's energy intensive, and excess application of fertilizer is also causing problem like eutrophication. To close this yield gap, we need to have additional input of fertilizer, which is shown by here. Y is the nutrient uptake by the crop in yields, and R is the nutrient uptake by the crop in residue while closing this yield gap. And this is the condition for 2010, the amount of fertilizer used in different countries. What we can say is amount of fertilizer used in Asia is very large than amount of fertilizer needed to close the crop yield gaps. But still, crop yield gaps prevail in Asia. That means the way we are applying our fertilizer is not so efficient. So in the future, when we talk about closing crop yield gap, we also need to focus about how we can make a fertilizer use more efficient. So we need to focus on fertilizer use efficiency, not only putting more and more fertilizer in our agriculture land. We can think about putting organic or inorganic fertilizer, but we need to fertilize our field, but we need to do that in much more efficient way than we are doing today. Another aspect about food is where we are going to produce food and where we are going to consume food. So that means we have a debate mainly, like people want to have the local food, local and regional food. But the question is, how local can we go in terms of food self-sufficiency? And in this analysis, what is shown is there are around 2 billion people that can be fed within their living space of around, let's say it's like, it's a 5-minute grid, so 10 by 10 kilometer, around 100 square kilometer. And there are around like 4 billion people, this is the analysis for 2000, so which can be fed within their country, and so on. This food self-sufficiency can be increased by reducing food waste. That's one of the important factors. And second thing is like food self-sufficiency in different scale can be also enhanced by closing crop yield gaps here. But the issue here is when we talk about local food self-sufficiency, these analyses are done taking into account only total calorie produced and consumed. This changes a lot, or this food self-sufficiency decreases a lot when we talk about different food groups. That means people may produce enough calories, but not enough diverse food to feed their population. That's why when we talk about food self-sufficiency on a local scale, it's not only consuming local, but also local food production need to be diverse enough to provide enough calories or enough diversity to feed the local population. And when we look at the future, what matters is population growth. Here, this is the scenario with population growth. So when we compare the population growth and dietary change, local food self-sufficiency decreases a lot when we consider dietary change. So it's not only population, future matter how the dietary change will be happening. And then here in the scenario group 3, it shows feed conversion efficiency. Whenever there is some technological progress here in terms of improving feed conversion efficiency of livestock, it will improve the food self-sufficiency. But still, diet matter a lot. Dietary change matter a lot in addition to growing population. And also climate change matter because we can see the fluctuation in food self-sufficiency across different climate scenarios. And when we talk about future food self-sufficiency, we need to focus about like our sustainable food system. We need to focus about urban food system rather than like a rural food system or something like that. Because today, more than 50% of the global population is living in cities. By 2050, around 75% of the global population will be living in cities. And here in this map, it shows the distance food need to be traveled for different urban locations. It's around 7,000 urban locations across the world. And here this simulation is based on optimized case where the food will come from nearest vicinity of the urban settlement. And what we can see is, depending upon the region, there are some region in South Asia, Southeast China, Europe, United States, where the food miles is relatively low. But there are some region like here in Japan or here in the coast of China, where the food miles is relatively high. And this is the case where food is coming from the nearest possible vicinity. Here, in some cases, the nearest possible vicinity may be 10,000 kilometers apart. And in some cases, it may be only 10 kilometers. And when we compare this with the cases where the food may come from any part of the world, like let's call it like a global extreme trade, where food can be coming from any part of the world, what we can see is the picture is really yellowish here. It doesn't matter, bigger a city is, higher productive the hinterland is, substantial amount of food miles is there when we go for extreme global trade compared to the optimization scenario. Why this matter? This matters because when we transport food, we are also emitting greenhouse gases. So food transportation is also contributing to climate change. What we can see here is that the food for greenhouse gas emission for food transportation for most of the cities is higher in the optimized is in the random or global trade scenario compared to the optimized case. But there are some countries where the food distance is quite large. Either it could be in an optimized case or on the random case. This could be the case for some mega cities in Southeast Asia. And when we look at the different cases like closing crop yield gap, food reduction of food waste, and looking at food group, what we can see is it varies a lot. The emission varies a lot. And when we compare to the actual emission from food transportation, it's around 0.3 gigaton CO2 equivalent per year. That's 0.3 gigaton is the transport emission due to food. And when we look at here, like we could halve the emission due to food transportation by optimizing our food system. This globalized scenario is a very extreme scenario, so let's not compare with that. But the real scenario is around 0.3 ton CO2 equivalent per year by transportation, and we could halve that. This could be enhanced by closing crop yield gap and also reducing food waste. But when we consider food waste, when we consider different food groups, this may change a bit. This may increase a bit here, and this is because of the monoculture, like we are producing a specific crop in a specific region, and what we can see here is that we are emitting a lot of greenhouse gases for transporting animal products. Here, consumption of animal product is also crucial in terms of food transportation, and for some exotic product like tea and coffee, it doesn't matter whether it's on a random trade or optimization case. So we can still enjoy tea and coffee produced in different locations of the world and not contributing to much emission. But we need to consume local animal product or local other products so that we can reduce the emission due to transportation. In a way, it doesn't matter. The share of emission is not much compared to the global emission. However, it matters because when we talk about future where there will be around 75% of the global population living in the cities, these are the different scenario analysis done, and what we can say is like emission due to food transport will increase further in the future. So we need to think about localizing or regionalizing our food system to reduce greenhouse gas emission, and this is quite crucial to achieve 1.5 degree target. Otherwise, if we don't have like a negative emission or zero emission, it will be really hard to achieve what we want to have during the Paris Agreement. So here, I try to draw few different components on food production side and food consumption side, and how can we make our system a bit smarter to enhance food security and sustainability. And these components are linked to several sustainable development goals. Here, zero hunger, sustainable cities and community, responsible consumption and production, climate action, these are the few I mentioned here. And we need to think about this because global leader has agreed to achieve SDGs by 2030. And when we talk about SDGs, what we need to remember is that this goal, all the goals may not be in line in the same direction when we look at traditional development. So there may be some synergies which is displayed by this greenish color here, or there are some trade-offs here among other goals. So, for example, there is a high synergy between goal 2 to reduce zero hunger and goal 1 no poverty. But when we talk about goal 12 sustainable consumption, there is a huge trade-off. And to achieve sustainable development goals by 2030, we need to leverage synergies, but also find ways to remove the trade-offs. Saying that, I would like to conclude my presentation saying to nourish the growing population, combination and sustainable implementation of following measures are required. We need to reduce food waste. We need to promote dietary change towards low animal product. We need to promote consumption of local and regional food. We need to promote our agricultural biodiversity. In the places where there are yield gap, we need to support agriculture intensification. In some cases, we also need to go for agriculture expansion, and definitely international food trade will play a crucial role in feeding the world hunger, feeding the growing population. And I would like to thank you for your attention, and I would like to acknowledge the support from my funders and my colleagues. Thank you very much.